Okay. Thanks for coming to this workshop today. So what this workshop is about is deploying your own personal copy of Prow. And how it came about that I wanted to do this and come up for the idea of this workshop was in Barcelona earlier on this year. I was at KubeCon, and at this event in KubeCon in Barcelona, I was looking for work to do on Kubernetes, and Tim Hawkins said to me, "Well, we have a lot of bash scripts, and there's some work that maybe you could do around that." And I said, "Okay, cool, excellent. I'll have a look at the bash scripts." He said, "We have too many bash scripts, and certain things happen with them, and casual passers-by sometimes go in and make a change to the scripts, but because it's so easy to, bash is a useful tool, but it can be a sharp one." So I had a look at the preponderance of bash scripts in the hack folder, and I happened upon a small issue relating to shell check. So shell check is a tool that is good for linting and checking the quality of your bash scripting, and it's used on the project, and it's very good. There was an error that was turned off for shell check, and that error related to when shell check lints your bash, if you include a file or if you source another bash script from your parent bash script, and if the path to that bash script is in any way dynamic, shell check cannot follow the path, and it'll emit a warning saying, I can't check this sourced file. So that warning was switched off. The workaround for shell check is that if you could annotate the script and say, shell check, this particular file that I'm trying to source, even though it's dynamic, I know it's here. So you can stick that into a comment, and shell check will then check that for you. So it'll check the parent script and then check the source scripts. So I thought it would be a good idea to go through 80 or so bash files and fix this problem. Now, and what I learned from that, there was a few things I learned from that is when people tell you pick a small thing to work on an open source project, there's kind of reasons for that, and my rationale and thinking was I knew that this wasn't a small change, but I was only adding a comment. Strictly speaking, it wasn't a functional change, and it was small, and I thought it was understandable, but it was across 80 files, and ultimately, when I submitted the pull request, a few jobs did fail, and it wasn't clear to me whether they were flaky tests or whether it was related to my change, but I generated a lot of project chatter on this pull requests, but I could sense and feel that the overall thing was, who are you? Why are you doing this? What's the benefit? There was good technical review on it, but really, from my point of view of my journey to become a Kubernetes contributor, I wanted to be able to run the tests. I wanted to see tests fail, but I didn't necessarily want to generate all of this project chatter and waste people's time. So I happened upon the idea of saying, okay, well let's see if I can do this at home. Let's see if I can deploy Prow on a local machine. So cut to a couple of months later, I submitted the idea for the talk, for this workshop, and then I forgot about it, and then it was accepted. So I've been working on this now for the past 4 or 5 weeks. And essentially what I've been doing is working off the getting started with Prow file in test-infra, and I've been working through that to make it work for scripted manual deployment. So in terms of my source material, this would be some of the links that I would have referenced in getting this set up. So specifically with deployment, the initial document for wrangling and getting Prow deployed is this guy here. So in this README here, in this markup file, what we have is we have a fairly detailed description of how to deploy Prow, and it's done from the point of view of serving the needs of the Kubernetes project, and on the main Prow instance that's running in GCP, and this goes through issues relating to running on GCP, and there is some tooling to help you deploy Prow. But what I've done here today and what I've pushed to my repo is manually, effectively, it's a scripted manual deployment of Prow. Okay, so I suppose in terms of how this works, this is the script. So if you go down to the bottom, I suppose. And in terms of a Kubernetes starting point and a Kubernetes journey and learning it, learning Kubernetes, deploying Prow is kind of a useful thing to do insofar as that basically I would have learned a lot about Kubernetes by trying to deploy this locally. Prow itself is kind of a microservices-based application, and there's several components in Prow. And I suppose I'll just, maybe if we just go through how I set about deploying it, that's what I'll do now. So, is that legible? I'll make it a little bit bigger. So, the first thing that I do is I'm using kind to set up the cluster on this laptop. And the first thing I do, I check to see if we already have a cluster, and if it is, I just tear it down and start over. Starting up the cluster is fairly straightforward. Okay. I'll do that. And there we have kind. We're just doing a kind create cluster. I give it the cluster name, and wait for that to come up. And kubectl cluster info then sets the context for the rest of the script, so that the following kubectl commands operate and work. One of the things that I would like to do with this code is to reference back to the parts of the document that instructed me on each of the steps. So the three kubectl commands at the end of the kind sort of bootstrap. These. So you can see the instructions here in terms of how I work through this. So here, for example, we're setting up config maps and as per instructions in that document. Okay. So moving on, once the kind cluster is up, it's time to deploy the starter YAML. So in test-infra, we have a starter YAML file that allows you to bring up Prow, and that is start starter YAML. Okay. That's this here. So this comes out of test-infra Prow cluster. There's a change I've had to make to that file in order to get this to work, and I will submit that as a PR after this talk. So that So on my journey in terms of deploying this, I've taken a few. I've used a lot of tooling to try and automate this as best I can. So one of the tools I looked at and used successfully at home was kapp, and kapp is a tool that allows you to deploy applications onto Kubernetes clusters. I like the tool from the point of view that it gives you before it makes the changes, it lists out how it's going to change the cluster and how your cluster will be modified by applying some configuration to that cluster. I'm not actually using it at the moment because for some reason that I couldn't chase down, it wouldn't work on the laptop today. So I quickly refactored these two functions to have a kubectl deploy Prow and a kapp deploy Prow. So kubectl works, so that's why I'm using that now. But essentially, that applies that. Then the second thing that I need to do then is I need to apply some configuration that pertains to my instance of Prow here. And for that, one of the instructions, and it's one of the instructions that I had to follow from here. I didn't want to do that. Was to basically pick out and find these tags for these containers that Plank uses. So there's a command there. You can see the kubectl get pod. That this basically will return that version for you. So I think I can actually run that. Now, what I do with this is, what I do with this, I actually run this in the script. Didn't work there, but this is part of the tricky business of doing this stuff from Bash, that without doing a deep dive on it, this kind of feels like an escapement problem in terms of all of the characters there. But I do have it up here. So here, what I do is I get this, I run that command and get that tag back, and I use another of the tools that sits alongside kapp called YTT, which I presume is YAML text templating, and I've only scratched the surface of what that tool can do, but essentially we have, if I vim config.yaml, here we have code inside in the YAML. It's a Python-esque type code, I think called Skylark. But this code here, that annotated comment introduces a piece of code that can be evaluated by YTT, and essentially we're concatenating data.values.prow image and concatenating that with that leading string. In order to use YTT, in order to use that, I need to have that comment at the top, that #@ comment. And because YTT is relying on annotated comments, the normal text-based comments that you have to introduce require an exclamation mark after the comment, so it knows to ignore that. So it's a comment within a comment for YTT. So I have a few issues with this in terms of right now, in order to get that image, I have to stand up the application, so that's something I'll work on in the future maybe. But the net result of this from the scripting point of view is that /YTT. So from the scripting point of view, it's not beautiful composition on this function, but that ytt-f space dot basically processes all of the YAML that's in the current directory, but then I'm left with the problem of, well, where do I put the resultant and the templated out YAML? So I just drop it into that /configured folder there. And then I run check config, which is an application that exists in test-infra to check your plugins and your config.yaml for Prow. So we may as well have a look and see how this runs. Any questions so far, or no? I'll crack on. Okay, so I have an instance up and running now, but I can kick it off again. Okay. So step one in terms of deployment is to run this. So you see there that's the output of check config, indicating, I think there's one warning there, and then indicating that, well, we can push through this. And this, the script is now bringing up kind. And takes the time. It's not a very powerful laptop. Like, there's loads of memory, but sort of 2 little cores that can in the CPU. So the ultimate goal that I wanted to achieve was to be able to run the Kubernetes jobs, and I've not got to that stage yet. So maybe the next time I give this talk, I will get those jobs configured and up and running. Although my fear is that the tests are too heavy to run on a sort of a laptop like this. So I need to do a survey of those jobs and figure out what can be brought up. Okay, so the application is actually up and running, even though there's that invalid value there. I can speak to that. I haven't done the deep dive on why this is. I have some references on what that's about, but it still runs. So here we have the pods that are brought up from the deployment. So when that's up and running, you should be able to. The way I manage ingress is to use another of the YTT kapp tools. I think the K18 tools, and that is here. I'll just make that a little bit smaller to get this. I won't stop and start this because this does take a time to start up. I'll leave that there. Control BC. But the command to kick this off, I'll is kwt net and service. I think I might need to check that. That's in the it's in the README on the repo for this. Yeah, it's net start. Yeah. So when I can only give a hand wavy explanation of this, but essentially this exposes the following URL out of the cluster, which should be deck service local, or it should do. Not quite sure why that's not working. I'm just going to go back here. What am I going to do here? Yeah, not quite sure why that's not working, but I should expect to see. Sometimes it can take a time to come up. And what I might do is just actually bounce this guy. It's probably good to do that because that gives some indication of what it's up to. Okay. So when that networking pod comes up, my expectation would be that that deck should display in the browser locally. Now, while we're waiting for that, I didn't mean to do that. I'll leave that run. And while we're waiting for that, the final piece, to kind of talk about in terms of what I've automated, is that when Prow, one of the core features of Prow is that it allows you to run commands on pull requests and have a GitHub hook-based interaction between Prow and GitHub. So, for example, if you run /test_all or if you enter test_all as a comment into your pull request, that will run all of the tests in Prow. And there's a little bit of a credential setup required to get that done. But I have used some tooling from test-infra to get that working. And I'll just show that now. Then, yeah, wrong place. So the ad hook code, what I do here is, at the core of it, is the ad hook command, which comes from test-infra. And what that does is it takes the public URL, and I've kind of, well, I suppose maybe I should handle how I do that first. So once I get the local instance on the laptop running, what I then do is set up a reverse SSH. I tunnel over SSH back to that from using ngrok. So ngrok, let me just see if that's coming up. Not coming up. Okay. So when I run this, I'll just show it running. So what's happening here is that what's happening here is that if I go to the repo and that I've set up in an organization that I've set up, I think we may have possibly some. Yeah, that's unfortunate, but I can talk through it. So basically, on a repo, you will have settings. There we go. We will have settings where we can set up webhooks for the repo. And if I just go to them here, that's webhooks there. And what that script does, and you can see it having run a few times. So ngrok basically. If I just have a look at that, that'll probably 500 out. Oh, lovely. The email address ages me a little bit, I think. Did I get that right? Yeah, okay. Lovely. I can do it as this, actually. I'm just going to go back and see if we have got this up. try again. Okay, so this is the webhook on this repo, and it's fairly straightforward to set it up manually. You just put in the payload URL, and so in my case here, this will be something that's available on the public internet, but will tunnel back to a non-public part of the internet where our Prow installation is. And what we need to have done here is we need the application type to be JSON, and then there are permissions that can be, I think there's permissions here when you set this up that are required to be set. So you can see here that this was an attempt to have a chat with that URL, and that has failed because this guy isn't. This guy's not coming back to me, unfortunately. But when that networking pod comes up, and when it manages the DNS, so that deck.service.local address will point into the application running on the cluster, and that wiring up does work, and it's reasonably straightforward to do. So that's in terms of, I know this has been more talky than workshoppy, but that is pretty much it, I think. Does anyone have any questions? It's reasonably straightforward in terms of the work itself. The code is a little bit there's a couple of things that could be done to improve the code, but the way I see that script sat alongside the documentation. Both of those things together would give you a good map of how you want to create your own Prow deployment. In terms of other projects that are using it, other projects have written about their deployment journey as well. I think Istio would be an example. But yeah, if there's no other questions, I think we could maybe wrap it up there. Yeah, question?
What are benefits of using Prow versus using it like active?
Yeah. So I'll repeat the question for, yeah, so the question is what are the benefits of using Prow and GitHub Actions as opposed to maybe say something else like Travis? There's a couple of, in terms of my CI comparison that I would make, based on my experience, I would compare Prow to Jenkins as follows. And we'd have people here who might be able to validate this or add to this, but my understanding is that from the needs of the Kubernetes project, Prow was built in order to handle the scale of contributions and the scale of testing that goes into Kubernetes. And from the point of view of the skill set and the team, there was a desire to kind of, I suppose, in a way, eat your own dog food, But from a scalability point of view, I believe the Prow is a lot more scalable and easy. It's not that Jenkins isn't scalable, but it requires a different set of skills in order to manage scaling out issues. From the point of view of workflow, in my opinion, the real benefits of Prow and the GitHub workflow that's used in Kubernetes is it's transparent, it's open, it's easy to understand as a developer and an end user, and the whole workflow that that Prow supports with its interaction with webhooks, it's not difficult to learn, and I think that sometimes you will see people from other communities and other open source projects say, "Oh, Kubernetes, how do you do it?" And there are talks on YouTube where you'll see people from the kernel community saying, "We don't know how you do it with GitHub, but once you understand how Prow works, you understand how Kubernetes as a project works." I think So I don't know a lot about Travis, but I know from looking at the pull requests that I'm looking at, it's a fairly easy end user interaction. It's a fairly easy user experience, you know.
You have like a, is there a site where we can, I guess, apply for jobs? Let's say that if I have an open source project and I want to use Prow, but I don't want to deploy it myself.
Can we turn this into a business? Is that what you're asking?
Well, that would be a separate.
Yeah, a separate question.
But I know right now, like, projects like mine use it, and the question is like, what if I want to use it? Like, where, is there an open source version of it?
I don't know. Do we have? Does any?
I don't work on Prow. I think there's a little bit missing sort of in comparison.
Yeah.
Like Travis is really about CI, so it's going to look at pushes and pull requests. Prow and GitHub Actions, for that matter. I work on GitHub Actions.
Yeah.
Look at a wide variety of things. So everything from pushes and pull requests to issues being commented on and created, and pull requests being created, not just merged, and labels being created, those kinds of things. So in theory, you could, and then Prow, of course, based on those interactions, whether it's somebody commenting on something or a variety of things, goes and runs a bunch of jobs and doesn't make it work, right? Which is essentially what GitHub Actions does. Very similar, kind of at that high level model. Now, Prow has a bunch of pre-built-in types of jobs and things like that, as I understand it, that do a lot of really useful things for the Kubernetes community. And it's very much about how Kubernetes works. So I mean, I would say that's a big difference between something like Prow and GitHub Actions versus Travis. Like it's sort of the breadth of things that you could do, or they enable you to do, versus sort of one very specific use case.
Cool.
One of the things that I was kind of curious, when I was looking at kind of the way that they're using it, if I, one of the jobs that I submitted, one of the jobs failed, and there was a bot that kind of came back, and that was only exactly what I had to, what I had to send as a message, so that it would keep calling that job again. I don't know if GitHub, on the action side, that the way that I'm using it, it failed, it failed. But I don't know if there's such a thing where I can say, hey, you know what, I have, I don't know, I have this set of steps that are individual, and one of them failed, and I only want to rerun that one, based on a simple comment.
So GitHub Actions itself doesn't have that feature built in. You could build it using Actions. I mean, like, to some degree, that's what has happened with Prow, right? Prow itself lets you do those things simply because it has a model or understanding about how it's expected to work and how things are expected to work, and then based on certain types of failures, well-known failures that have been learned over time, right, you can respond back. And it's a similar problem. I think one of the challenges is every project's a little different, every source base is a little different, so you can't really like stamp out that workflow necessarily for a whole bunch of projects.
The other thing I did notice was your parallel jobs running. So is that something that was sort of specifically for Kind, or is that inherent on Prow itself, where you can say, I have this set of jobs, and I want to flag it in a way that they can be parallel?
Well, my understanding is, and sadly, I didn't get into job configuration for this talk. My understanding would be that you could orchestrate, you should be able to orchestrate jobs in parallel, but it's a bit hand wavy for me now. I wouldn't have that experience. But yeah, I think that's something that can be done. Yeah. Okay. Any other questions? Okay. We'll wrap it there then. Thanks for coming along to the talk. Thank you very much. Cheers.